Hi guys, today's GFG POTD problem is reverse the first k elements of Q. Okay, and we will sit back go into the question here. Like there is an array, there is a queue here, there is a given queue, and with n elements, right? And also there is we are given with k, okay, that are the number of operations we need to perform, the number of elements we need to remove from it, and we need to reorder the order of the k elements, right? We have to reorder the order of the k elements. Okay. For suppose the first three elements of one, 1, 2, 3, 4 for Q are 1, 2, 3. So the output should be 3, 2, 1, and 4, 5. Right? So the output should be in this way. So we need to change the first k elements order, not the remaining elements, right? Remaining elements order should be same, but the first k elements order should be same, should be changed here. So take a pause here and try to solve the question on your own, so that you can. So if you want to get any solution, you can watch this video for the solution. Okay, and so coming to this problem here, and so the first step, whenever we want to change the order of first k elements, is we can use a data structure, right? So for changing the first k elements order, we need to have a data structure to store the first k elements of a queue, right? Okay, and so we need to have first uh, we need to store the first k elements of the queue. So we need to have the reverse order of the first k elements, right? So what will be the case, like if we what what type of data structure we can take? We can take any type of data structure, but in in an easy term, we can take a stack, right? Whatever the last element we get, we can access that we can access that element first, right? So with that we can get the reverse order case uh, of the first k elements, right? So in this way we can take stack as our data structure, integer st. Okay, okay. So we need to store first k elements. So we need to check whether our q dot size is not equal to null, and k is also not equal to null. Okay, so now we need to remove the element from k, and we need to add it to the stack, right? So st dot push equal to q dot remove and k minus minus, right? So this is the first step we need to do. Here we need to remove the first k elements, and we need to store it into the data structure. Okay, and after that uh, we need to also have the order of these elements same, right? So in, or- in order to have the order of the elements same, we can use another data structure called queue, right? So first queue here for storing the remaining elements here, right? Let's take a here, right? So while q dot size not equal to 0, not equal to 0, then I can simply add a dot add q dot remove, right? Why am I doing this thing? To maintain the order of the n minus k elements here. Okay, last n minus k elements here. Okay, so after doing this, first we need to we need to have the first k elements in an reordered form that should be present in the queue, right? First the reordered k elements should be in the queue, right? Further, we need to take from like we need to pop it from s profit pop it from stack, and we need to uh, push into our queue, right? So initially I will our queue until here our queue will be empty here. So in an empty we need to push the first we need to push the reordered elements that are 3 to 1, right? So 3 to 1 order will be set by stack, right? So if st dot size not equal to 0, then we can simply push st dot pop, right? Okay, and again uh, we need to pop pop off all the elements from EAQ, and we need to replace it in the QQ, right? So original queue, while a dot size not equal to 0, a dot size not equal to 0, a dot q dot add a dot remove. Okay, and finally we can return our original queue here. Our original queue contains the reordered k elements and n minus k elements here. Okay, in this form. Okay, this is the pseudocode of this problem. And coming to the problem of this, coming to the original problem here, and see, so uh, we will be doing here in our stack. In our stack, our first three elements will be there, right? So our first three elements are 1 comma 2 comma 3, and in our queue new queue, that is a our last two elements, right? And 4 comma 5. So our queue will be initially empty, right? So after doing that, we need to pop all the elements from stack to queue. So when we pop from stack, we will get the last element, right? Last in first of uh, whatever the last element we were uh, pushing into our stack, that will be popped out, right? So the last element which I pushed into it was 3, right? So 3 will be popped out and it will be stored in a queue. And now in this way 2 will be popped out and push it into the stack, and in this way 1 will be popped out. Now the stack will be empty, and we need to remove these 4 5 terms into from A, and we need to replace it to 5, right? So what is the difference between queue and stack is stack is basically last in first out, we can also say that LIFO. So remember this, LIFO property holds good for stack, which is last in first out. Whatever the last element was pushed into stack, that will be emitted out, that will be popped out first, right? This is the LIFO property. And Q property is first in first out, that is FIFO property. So element whatever the first element we pushed into our queue, that will be coming out first, that will be coming out first. Okay. And so this is the stack and queue here. With the help of stack and queue, we were able to achieve this problem here. And coming to the complexity here, big of n is the TC here. And coming to the space here, big of k at max, k we are k elements we are storing, right? So and it will be CC SCA, like space complexity. So this is the problem here, and thank you.